Good morning. Before starting power series, there are two questions that are expected one, and these questions having a very nice concept for finding the analytic function using the Milne Thompson method. So we have to start these two questions. So let's have a start. Find the analytic function fz equal to u plus iota v given that u plus v is e the power minus x cos y plus sin y. Now here the sum u plus v is given. So how to do this? We have f of z is equal to u plus iota v. If I multiply iota with this whole equation, I will be getting iota u minus v. So I'm having u plus v over here and I'm having the real part as u and minus v. So what I have to do, if I subtract these two equations, then I will get u plus v because I'm having u plus v over here. So on subtracting, I will get 1 minus iota f of z is equal to, see your real parts, that will become u plus v and plus iota, this is v minus u. Okay, so take this real part u plus v as capital U plus iota, take this v minus u as capital V. This is your imaginary part that is equal to v, and this is your real part that I have taken capital U. Okay, so your u is equal to, now u plus v, that is u is e the power minus x cos of y plus sin of y, and your capital V is v minus u. So let's start. Let's check whether this u is a harmonic function or not. For that, differentiating u with respect to x, this is minus e the power minus x cos of y plus sin of y. Then again differentiate, this is e the power minus x cos of y plus sin of y. Now differentiating with respect to y, this is e the power minus x minus sin y plus cos y. Again differentiating with respect to y, this is e the power minus x minus cos y minus sin y. So if you see these two equations, del square u over del x square and del square u over del y square, these are having the opposite sign, they both cancel each other, so this addition is 0. Now del square u over del y square, this sum is 0, so u is a harmonic function. It is a harmonic function. Now as this u is a harmonic function, we have to write u is real part of some analytic function. Now here fz, now analytic function is to be introduced, so I should write u is a real part of some analytic function. And what is that analytic function? Let that be equal to u plus iota v, and where v is the harmonic conjugate of u. Okay, what is my equation that I have in the previous page? That is 1 minus iota fz is u plus iota v. Okay, so 1 minus iota fz is u plus iota v. I am having only u. So if I check this f dash z, this is equal to del u over del x plus iota del v over del x, just जो हमारे पास पहले होता था f dash z. अब यहाँ पर because I'm having u, so I have to change the second term, that is minus iota in u, del u over del y. So now putting the values, what is del u over del x? That is equal to minus e the power minus x cos of y plus sine of y minus iota. What is del u over del y? That is equal to e the power minus x minus sine of y plus cos of y. If you solve this, you e the power minus x, you will get cos of y plus sine of y, taking minus inside and e the power minus x outside, you will get sine of y minus cos of y. Now using the Milne Thompson method, one minus iota f dash z is equal to, this is minus e the power minus z, cos 0 is 1 plus iota e the power minus z, sin y is 0, this is minus 1. So this is equal to minus e the power minus z 1 plus iota. So now if I integrate, on integration I get f of z is equal to, this is e the power minus z 1 plus iota plus alpha. Okay, if I integrate, I will get this. Now this is okay. I take 1 minus iota on the other side. F of z is equal to 1 plus iota over 1 minus iota e the power minus z plus alpha over 1 minus iota. Take this whole constant to be equal to c. So you will get f of z is equal to 1 plus iota 1 minus iota e the power minus z plus that constant. Or if you rationalize this, that is 1 plus iota over 1 minus iota, change this to 1 plus iota over 1 plus, you multiply, divide by 1 plus iota. Finally, it will come iota e the power minus z plus constant. This is your required analytic function. Now the second question is, if u minus v, now here now u minus v is given and fz equal to u plus iota v is an analytic function of z. Now it is also given that fz is analytic function. Find fz in terms of z. So f of z is equal to u plus iota v multiplying with iota again. This is minus v plus iota u. Now I have to get u minus v, so I have to add these two equations. On adding, I will get 1 plus iota f of z is equal to u minus v plus iota v plus u. So now take this u minus v as capital U plus iota, this is capital V. So u is x minus y, which is given, u minus v, which is given x square plus 4xy plus y square, and v is v plus u. Take this as 1. Now should I check u is harmonic or not? Yes. No, I should not check because it is given that fz is analytic function. So if fz is analytic, then u plus iota v is also analytic, and if u plus iota v is analytic, so obviously u and v are harmonic functions. So there is no need of checking this harmonic or not. These are automatically harmonic functions. So just write that equation for finding fz, that is, I'm having 1 plus iota f of z is equal to u plus iota v. Since f of z is analytic function, so u plus iota v is also analytic. Alright. Now 1 plus iota f dash z is equal to del u over del x minus iota, plus iota del v over del x. Now I'm having my u only with me, so I have to again change the second term and we write del u over del y using the CR equation. This is f dash z. Now what is del u over del x? We have u with us, so just derivate u with respect to x. You get 3x square plus, on solving, 6xy minus 3y square. You have to check on your own, minus iota del u over del y. If you find, then on solving you will be getting 3x square minus 6xy minus 3y square. Now use the Milne Thompson method. By Milne Thompson method, we put y is equal to 0 and replace x by z. So this is 3z square, this is 0, this is 0, minus iota, this is again 3z square, this term is 0 and this term is also 0. So this is f dash z equal to, taking 3z square common, this will become 1 minus iota. So on integration, we integrate one plus iota f z is equal to, this is z cube 1 minus iota plus constant. Now taking 1 plus iota to the other side, this is z cube 1 minus iota over 1 plus iota plus c over 1 plus iota. Take this as alpha. You can take c, but I am taking alpha. That is also a constant. So f of z is equal to, you rationalize this term, that is multiplying with 1 minus iota, also dividing with 1 minus iota. This constant will be taken to be as c. So f of z is equal to, this comes up to be minus iota z cube. You solve this on your own, plus this constant, which is the required analytic function. So this is how we use this is how we have used capital U in place of u plus v and or u minus v. This is how we have to do these type of questions. So next time we will be start power series. Thanks for watching. Do subscribe my channel so that you will be in touch with the latest videos on complex analysis. Thank you.